you're trying to put a puzzle together, you look for pieces that fit, right? Hey, these pieces seem to fit, but despite the appeared match, this picture is not what we wanted. That's kind of what happens in the immune system when someone has an allergic reaction. We can pinpoint the culprits of allergic reactions to 3 immune cells: B cells, T cells, and mast cells. These 3 cells are part of the adaptive immune system, the sector of the immune system that targets specific pathogens and stores those pathogens in the immune memory in case the threat reemerges. So let's start off with the B cell, which is developed in the bone marrow. While in the bone marrow, each individual B cell creates its own puzzle piece called an antibody. The antibody is generated in hopes that it will find a piece that fits. That piece is called an antigen, which is kind of like the body part of an invader. Because antibodies are generated randomly, a B cell can end up making one that fits with something you don't want your immune system to attack. We call these substances that are mistaken for pathogens allergens. Thankfully, the B cell can't just automatically start attacking its matching puzzle piece. After the B cell goes into the bloodstream and finds an antigen that fits, it must wait because it is still naive. A naive B cell waits for a T cell to give it the okay, like how a teacher might approve your paper. If a T cell comes by that has a match called a receptor, then the B cell gets the okay to start cloning itself and releasing its antibodies into the bloodstream. Sometimes, the T cell's receptor also happens to fit with the B cell, despite the mislabeling of an allergen. So the B cell succeeds at cloning itself and spewing its faulty antibodies everywhere. With most allergies, these antibodies are classified as the type called IgE. IgE antibodies happen to have a high affinity for mast cells, which means that they are very attracted to each other. When an IgE antibody bound to an allergen binds itself to a mast cell, that triggers the mast cell to release a sac of chemicals, which includes histamine. The process of sac emptying is called degranulation. The chemicals released do several things, such as increased production of mucus, which turns your nose into a trumpet. Histamine also causes your blood vessels to widen and become more permeable. The permeability leads to fluids leaking out of your vessels, which is how you get hives. On the more severe end of the spectrum, the widening and permeability of blood vessels can lead to low blood pressure, which means the blood is no longer flowing as well and thus your body is deprived of oxygen. When your body is deprived of too much oxygen, this can cause anaphylaxis, which can be fatal. The chemicals released through degranulation also trigger your smooth muscles to constrict, which is what happens when someone's throat closes up. And remember, this is all part of your adaptive immune system, which logs everything in its memory. So now you have to worry about this happening all over again if you re-encounter your allergen. Luckily, there are medications such as antihistamines and epinephrine that prevent your immune system from going berserk on you if you re-encounter your allergen. That way, even when the puzzle pieces that aren't supposed to fit do so anyway, you'll be prepared to fight the enemy within.